Hi, welcome to another tutorial from Robojax. In this tutorial we are going to learn how we can use light dependent resistor LDR with Arduino so we can read the value of it and use it for some purpose. Let's get started. I have another video explaining fully LDR and how to calculate some resistor that you put in series with the LDR. So I will not go through that. But this one, very briefly, I'm going to cover what LDR is. And then we will look at it, how it can be used with Arduino. So this is an LDR, light dependent resistance. So it has a surface with two pins here, so which you can connect. So when the light shines here, depending on the type, usually when the light shines here, the resistance decreases. So it becomes like a wire. And when it's dark, it shows a lot of resistance on the path of the current that passes. If I put it this way, you will see it better. So that on the path of current, there will be resistance. So when light shines, the resistance decreases. When it's dark, the resistance increases, so the current cannot pass. But there is another type that acts in the opposite. I'm going to put a light dependent resistance LDR with a resistor like this. So this will be connected to plus 5 volt and this is connected to the ground or 0. So the two wires from 5 volts, this is positive, this is negative, so they will be connected here. And then we are going to measure the voltage here and then use it for analog 0 of Arduino. So we will connect this point to Arduino. Now let's measure here without anything. With at these 2 points, I'm gonna connect my multimeter, my voltmeter. I will connect it here and here to see what happens. This is the 5 volts. So the 5 volt is connected to the LDR here, and LDR is connected via a 3.3 kilo ohm to the ground. So this blue is the ground. So this is LDR connected to 5 volts and then it's connected to this resistor and to the ground. Now these are the two leads that are connected to the multimeter. I'm going to connect it here and then I'm going to put another wire, or maybe simply I'm connecting it here to the positive. As you can see, we are reading 3.85 volts across the resistor. Now when I bring my hand over, it becomes darker and the resistance increases and the voltage across the LDR will increase at the two sides of LDR that we measure. As a result, so the remaining of the voltage goes across this resistor, which decreases. Now you see it's 2.2 volts and when I remove my hand it's 3.85 volts. So now I'm shining light. As you can see, it's 4 volts. Remove it, 3 volts, make it dark, 2 volts, even fully cover it, it will decrease further. Stick to the 5 volts and then it comes to the LDR, light dependent resistance, and then I have a resistor here and then this side at the bottom is connected to the negative. And between the LDR and the resistor here, this is connected to analog 0. To Arduino. This is the Arduino board. And this is now 3.3 kilo ohm. This is 3.3 kilo ohm resistor. And here on the circuit, the top line, this is connected to positive 5 volts, and then here this is connected to negative, and the LDR is connected to, this is connected to analog 0, which I'm going to connect here. So this is now connected to, as you can see here, to analog 0. So ground and 5 has been taken from here. The code for this project will be available at robojax.com/learn/Arduino. The link will be at the description so you can go and directly download it. Now I'm uploading the code into Arduino and my serial port is open. So now it shows 4.7 volts constantly. So let me explain the code here. Analog 0 is read with this function. This is the full Arduino function. It says go and read analog 0, and the value is an integer. Actually what we read is between 0 and 1023. So this will get something between 0 and 1023 from this point. And then we are saying we are mapping, and we are mapping it proportionally. So because the voltage is 5 volts divided by the maximum value that we have, and then multiply this, so we will get the actual voltage. So this is the voltage that we get. Float means it has some decimal points, so that this is the type. This integer is also the type, so we are getting a value voltage here. And here this line, serial.print voltage with equal sign, this is this text, voltage with equal sign, and after the equal sign I print actual voltage, this value, and then creating a new line and waiting 300 milliseconds, and it goes. Because this is loop, it just goes. At the top we are just set up the serial port, which if you don't know it, just you have to put this in order for the serial port to work. So quickly go to device manager. I'm opening the device manager for you. Here, this is the port that I'm using. If I double click on the port setting, here it says bit rate, bit per second, which is called baud 96, and these values. So this 9600 refers to this value. I'm reading 4 because I've selected 3.3 kilo ohm resistance here. So now if I make it darker, as you can see, if I bring my hand over, we are reading 3.2 volts. If I make it more dark, I put my finger over it, as you can see now we are reading 2.2 volts, around 2 volts. So at the maximum brightness it goes around 4 volts, or maybe, let me just turn my flashlight and see. If I do my phone flashlight, so 4.83, so it goes up to 4.9 volts if I put my light fully, and if I darken it and fully cover it with my hand, it's 1.9 volts. So with this voltage that this one prints, so that you can do something. For example, you can say if the voltage reaches 2.3 volts, some light should be on, something should be turned on. So this voltage can be used, you can do something with it. If you want to have more control over the sensitivity of it, you can put a potentiometer. Potentiometer is a variable resistor that you can change the value within certain range. So let me look at a circuit now. So you have a variable resistor like that, so that's the middle point. This goes here, the bottom goes here. On the actual variable resistance, so this is how it looks. This is multi-turn, so there are different type of variable resistance. It has 3 pin. So this is pin 1, pin 2, and the ground is pin 3, this port. So this is 1, 2, 3, this way. So 2 is the middle one. Okay, so the potentiometer has 3 pins. These 3 pins, I'm putting it here. So now pin 1, pin 2, pin 3 are here. So from these 3 pins that I inserted. So pin 1, I'm just inserting it to pin 1, this wire, and it goes to the variable resistance. Pin 2 at the middle is where this goes to the A0, and pin 3 I'm inserting it into ground. Now as you can see, whatever value that we have is my screen is showing 0.5 at the bright light, which the other one was around 3. But I can get my screwdriver and then change it, see at the bright light, at the current light, what it shows. So as you can see here, just look at the bottom line. We are reading the last one. I'm turning it right, so this is decreasing the voltage as I turn it right. So you're getting a very small voltage, or if you want, I'm doing it counterclockwise. Let's say at certain light level, like this light that I have, you want the normal light, this should be 1.36, or if you want it, let's say 2 volts at certain light. So you want it at around 2 volts, and then when it's dark, and it should change to 1.3. So with this potentiometer, it can change to 0.7 volts difference between dark and light. You can adjust it to get your certain value, or you can also change the value here with some other, multiplied by some other fraction, or multiplied by some other factor. Now I've set the pin 10 as output, and here it writes the pin 10 high, so that is a pin 10. This LED is connected, this wire from pin 10 is connected here through the LED through a 680 ohm resistor to the ground, and this LED is on. So let's say you want to keep this on when the voltage here is less than 3 volts. When I cover this, you can see the voltage is 2 point something, and when I remove it, let's say if the voltage is less than 3 volts, the light should be on, otherwise it should be off. So here, if voltage is smaller than 3, so then we put this condition. So here this line says if the voltage is this voltage, the same thing. If the voltage is smaller than 3, then this is high, otherwise we will say else. Digital right, low. So we keep it low. Now I upload the code. Okay, so as you can see, this is 4 volts and the LED is off. And if I put my hand here, it's less than 3 volts. As you can see, the 4 volts, the LED is on. So when I make it dark, the LED is on. So at any voltage that you wish, you can make adjustment. Instead of LED, this line can be connected, pin 10 can be connected to a relay, and the relay can turn on an actual big light or a motor or another robotic arm. That was a brief introduction of using LDR with Arduino. Thank you for watching.